Hello class. In this recorded lecture, we are going to see how we can build a simple decision tree model using Rapidminer. So I hope that you have already installed Rapidminer and you have already launched it. So if you run the Rapidminer, you're going to see this user interface. So I'm going to close this welcome window here. And when you close it, you're going to see three, basically, four major panels that are related to what we are going to do. First, you have repository where you're going to save your files and your processes. Then you're going to have the operators where you can find a specific algorithm or functions that you're going to use for your analysis. After that, you have the process window here where you are going to build the models using different nodes. And for every single node, you're going to see the related parameters that you can change, or modify based on the need of your analysis. So for this simple, basically presentation, I'm going to use the data that is available for us under the sample data in Rapidminer. So I'm going to drag deals data into processes. And easily, in order to see what do I have in my data, you're going to see this out basically node here. I'm going to connect that out node to result here in the Rapidminer. When I do that, and if I go ahead and run this node, you're going to see the data and the statistics and everything. So this is our data. As you can see, we have future customer, age, gender, and payment method. So in this basically scenario, what we are going to do is we are going to see whether we can use the payment method, gender, and age of our customers to predict whether the customer is going to be our future customer or not. Okay, so in other words, the future customer is a labeled data that is labeled by someone in the retail, so they know that this individual has been the future basically customer or not. So we do have that information, and based on this label data, we are going to see whether payment method, gender, and age as independent variables can predict the future customer's likelihood. Okay. So if you click on the statistics, you're going to see that we don't have any missing values in our data. So again, since we are going to use the decision tree model, we don't care that much about the missing values in our data. And you can basically you can click on the visualization nodes to see basically the distribution of your variables, but it's not necessary for our case because since you are going to use decision tree, we don't care that much about the distribution of our variables. Also, for this class presentation and also the assignment, we try to ignore the data pre-processing and the data preparation phase, which takes a lot of time in data mining projects. So we are going to see how we can easily build the model and interpret the model. So that's our main task. So we are going to basically skip those processes. If you take more advanced classes, you're going to learn about those steps. So we don't worry about that in this demo. So I'm going to click on design view. Okay, so as you can see, I retrieve my data. I just pull my data, I put it inside the process flow, and it is ready for analysis. Now I'm going to delete that basically link from out to result here because I'm going to connect my retrieved data to other nodes. If you remember we're supposed to split our data into training and validation data sets, right? But before that, I have to specify which variable is going to be our dependent variable in our analysis. In order to do that, so I'm going to search for set role in my operators. You see the function here, I'm going to drag it here. From the output of the retrieve deals, I'm going to drag it inside the input node of the set role. Then I'm going to click on the set role. When you click on the set role, you're going to see the parameters related to this function. So I'm going to select the future customer attribute or field in my data set, and I'm going to say that, okay, it's going to be my label data. That means my target variable or dependent variable is going to be future customer. So I specify that. After that, the next step is to split our data into training and validation data set. If you remember, we are going to build model based on the training data set and apply the model on the validation data set to see how well the model perform, right? In order to do that, I'm going to search for a split data. Split data and drag it inside the processes. All right. And okay, so from the set role, I'm going to drag it inside the split data. Then I'm going to click on the split data node to make sure that the parameters related to split data is active. And then I'm going to click on edit button here. Then I'm going to specify the proportion of the training and validation data set. First, I'm going to click on add entry. The first entry that I'm going to have here is related to training data set. That means 0.7 or 70% of data is going to be training data set. And then I'm going to hit add entry again and type 0.3. That means 30% of my data going to be validation data set, and then hit OK. So I input the data. I said that the future customer going to be dependent variable in this analysis. Then I split data into training and validation data set. Now I'm going to apply decision tree model to my training data set, okay? And then going to evaluate the performance on the validation data set. To begin with, I'm going to search for decision tree model, decision tree, and I'm going to drag it here. All right. So I'm going to drag from partition 1, which is the training data set, into decision tree model, okay? And after that, to just see how the decision tree model works on the training data set, I'm going to show you just quickly the output of this decision tree model based on the training data set. So I'm going to drag from model to result to see how the model works. But we are not done yet. So we are going to see how the decision tree model works on the training data set. So I'm going to run it. Okay. So as you remember, in the previous lecture, I mentioned that the very first node in the decision tree is the most important node, for analysis. In other words, the most influential node in making decision whether someone going to be future customer or not is going to be age. So as you can see, if age of someone is greater than 72.5, they are not going to be future customer, right? Less than 72.5, it depends on gender. For female, greater than 31 years old, we have no future customer. However, if they are less than 31 years old, the decision to be whether they are going to be our future customer or not depends on the type of or method of payment. If they use credit card, they are going to be future customer. Otherwise, if they use other method of payment, they are not going to be future customer. So as you can see, it's very easy to interpret decision tree model. So decision tree learned that basically learn this model from the training dataset. So once decision tree learn this model, we are going to apply this decision tree model to the validation dataset to see how accurate is our prediction. So I'm gonna remove this node here or link here. So 30%. So from the training dataset, I use training dataset as the input of the decision tree model. Then I'm going to search for another node, which is apply model. I'm going to drag it here. Okay. How it works here is I'm going to say that, all right, I'm going to apply the model, decision tree model, to the apply model, the model that is learned based on the training data set. And I'm going to see how the model is going to perform based on the validation data set, which is the second partition in the split data, right? So I'm going to drag the validation data set to here. So it means that go ahead and apply the decision tree model based on the training data set to the validation data set, okay? Once you apply it, then we are going to see two different outcomes. First, we are going to understand how accurate our model is, okay? In order to do that, I'm going to search for performance. And I'm going to select the performance for classification, which is a task that we are going to do here because we are doing classification here. So from the label, I'm going to drag it to the label here. All right. And before I complete other parts, it is important to know that for decision tree model, if you click on it, you're going to see the parameters. However, we are not going to change anything. We are going to use the default setting here. And in the apply model, there is no parameter to modify. Similarly, in the model performance, as you remember from previous lecture, we are going to use accuracy, which means the number of true positive plus true negatives divided by all the cases in our analysis. So we're going to see those results later. All right. However, in the meantime, I just want you to pay attention to two things, okay? In other words, to the most part, we are done with this analysis. What we have to do here is we need to drag from the performance node to the result to see the accuracy of our model. And finally, we are going to see the decision tree model as well. So I'm going to drag from the model in the apply model to the result to see both decision tree and also the performance of our or the accuracy of our decision tree model. So I'm going to run this model. All right. So as you can see, we have two outputs. We have the decision tree, which is the same decision tree that we saw in our training analysis. So it hasn't been changed. So it is basically the same model. The model that has been trained in the training data set has been applied to the validation data set. So this is the model that that has been trained in the training data set, our previous decision tree model, which is used in the validation data set as well. So the new analysis that we have here is the performance vector or the accuracy here. So you're going to see that the accuracy of our model is 99%. That means among all the cases that we have in our analysis, only we have 3 misclassified cases. So as you can see, we do have the two false negative and one false positive cases. In other words, the number of true positive and true negative cases divided by the total cases is 99%. That means our model is very accurate and reliable to apply. So, so there are other metrics for the analysis, such as precision and recall. They are mostly important in other fields, such as medical science. But the accuracy metrics is very standard, measure to metrics to measure the performance of classifiers. So as you see, folks, it's very easy to build models. So instead of decision tree model, you can have another algorithm or classifier, such as regression or basically regression trees or other classifiers. So it's very easy to add algorithm to these processes and check different models. So instead of decision tree, we can compare a couple of models together and pick the best model, right? However, the intention of this demo was to show you how we can just build a simple model in Rapidminer, just for you to learn about the machine learning process in a very simplified basic format. So we input the data, we set the role, we split the data into training and validation data set, we train the data using decision tree. So for the training data, we use decision tree model to train the data. And after that, we use the model that has been built up in the training data set, we apply it to the training data set to see how the model performs. And after that, we check the performance of the model using the accuracy of the model. And finally, we manage to see both the decision tree, how it works, and also the performance of the decision tree model on the validation data set. So I think that it's very easy to build decision tree model. So for your assignment, what you are going to do is you're going to exactly build the same model using different data set, okay? There is no magic, no trick here. What you have to do is you have to just replicate what I show you here and apply it on a new data set and report a couple of stuff for me. All right, I hope that you understand this process. And please let me know if you have any questions or concerns. Thank you much for listening to this presentation.